Hello, everyone. Welcome the Canadian Science Policy Center's conference, 2022 pre-conference session. So this is our first short talk session, which will feature 5 short talks from a range of very interesting subjects and accomplished speakers. Each talk will be about 8 minutes of presentation, followed by 2 to 3 minutes of questions. We request you to please submit your questions through the Q&A at the bottom of the screen. And we also request you to please upvote preferred questions so we can ask those. So we will begin with our first short talk from Catherine Hayashi, who is from the Triumph Innovations.
Thanks very much. Hi, I'm Catherine Hayashi. I'm the CEO at Triumph Innovations, which is the commercialization arm for Triumph. So Triumph is home to, I'm just going to show you behind me, the world's largest cyclotron. It's a 520 million electron volt cyclotron, the largest of its kind in the world. We do a lot of experiments where we look for the missing dark matter in the universe and try to figure out what happens when neutron stars collide. But we also do a lot of work with medical isotopes, and that's what I'm here to talk to you today about. Can I have the title slide, please? Our opportunity to become a medical isotope superpower for the next generation of medicine. Commonly used medical isotopes. So many of us have experienced medical isotopes as part of the medical imaging and treatment that we have received. These are a list of some of the most common ones that are often used to image your skeleton, heart, brain, kidneys, looking for cancer. So the next slide, please. And here's a example of, sorry, could I have the next slide? Here's an example of medical isotopes in use. You may have severe shin splints and suspect that you have a stress fracture. So one of the ways that they can diagnose what's actually going on is an injection with technecium-99m, a medical isotope. Then they rescan. Areas that have unusually high bone growth show up on the scan, and this enables us to diagnose arthritis and other bone abnormalities. Next slide, please. But there's a really exciting, a new generation of isotopes that are showing promise as new cancer treatments. And so this is an example of one. Lutetium-177 is the medical isotope. It is part of a treatment called Lutathera for neuroendocrine cancers. Sales have increased to $441 million in 2019, and this is expected to be a $2 billion a year drug. Next slide, please. And this is sort of the really exciting piece, and where Triumph and many of the other Canadian institutions come in. There's something called targeted radiation therapy, and how it works is a medical isotope, which is a radioactive compound, is linked to a targeting molecule that targets specifically to a specific type of cancer cell. And if you're interested in learning more about this, there's a wonderful documentary that was produced by some independent filmmakers in Vancouver at rarestdrug.com. You can hear the whole story. It's only 10 minutes long, but it's a great introduction. But briefly, in the next slide, please. This is why everyone is so excited about this type of targeted radionuclide therapy. So in the patient scan that you see, this is a patient with advanced metastasized prostate cancer. So that means that the prostate cancer has spread from this patient, from their prostate gland into the bones. So the black that you see on the leftmost image is cancer cells in the hips, in the spine, in the rib cage, in the shoulders. A patient like this would have failed radiotherapy and chemotherapy therapy and would typically have only 3 to 6 months left to live with no further treatment options. The image in the middle is the same patient after 3 treatments with actinium-225 that is targeted specifically to prostate cancer using this radioligand called PSMA-617. 3 treatments later, and so the original scan was December 2014. The middle scan is July 2015. You can see that almost all of the cancer has disappeared from this patient's skeleton, which is a remarkable result. Very exciting. In this particular instance, this patient was given 1 additional treatment, and so by September 2015, not only is the visible cancer gone, they have dropped down to a PSA level, which indicates that they are in remission. So, an amazing result. One of the problems with this treatment is that the world supply of actinium-225 is only enough for a few thousand patients in the world per year. But we are working hard to increase that supply because we have the world's largest cyclotron with a very powerful beam. We can produce we have the capacity to produce tens of thousands of doses of this isotope, and we are working to modify and scale up our production at Triumph. We've done so in partnership with a Canadian radiopharmaceutical company called Fusion Pharmaceuticals, which is a spin-off of McMaster and the Center for Probe Development and Commercialization. And we partnered with another Canadian company, BWXT Medical, to also increase this supply. So a really exciting opportunity for Canada to be a key supplier in the globe. Next slide, please. And we can see that this market has an enormous opportunity for growth, far beyond other sectors. And Canada, because we have cyclotrons and nuclear reactors that can produce these medical isotopes as a sideline or a byproduct of our regular operations, we have an opportunity to really position ourselves as a global leader in this new space. But it will take additional infrastructure investments and new personnel to staff these kind of new initiatives. Next slide, please. So commercial opportunities are growing very rapidly. We do have Novartis moving into this space. So the treatment that you saw in that earlier patient slide was acquired by Novartis for $2 billion. They recently got their FDA approval. They've brand named it Pluvicto. They expect it to be a $2 billion plus drug for them. We also have a Canadian company called Point Biopharma that's also developing drugs in this space. Next slide, please. And as I said, we do have a remarkable infrastructure in Canada, as well as research and development capabilities. Everything from cyclotrons to power reactors that are specifically able to produce medical isotopes in addition to nuclear power. Researchers at McMaster, UBC, BC Cancer, Princess Margaret, Fusion Pharmaceuticals, spin-offs like Abdera and Alpha 9 in Vancouver are all pioneering work in this space. And we do have a policy and operating framework that can accelerate collaboration and innovation in this space and provide Canada a global advantage. Next slide, please. So part of what we've done as a community in the medical isotope world has banded together to submit a proposal to Canada's Strategic Innovation Fund. And we think that funds like this are really important for us to be able to develop the collaboration opportunities that we need to advance this opportunity for Canada. Next slide, please. Our application goes coast to coast, includes the major stakeholders in the sector. Next slide, please. And this is just an overview again of the concept, is that we really want to fortify all pieces of the supply chain, everything from R&D to develop new therapeutics and diagnostics, the commercialization of those, and then the isotope supply and production. If we have all of the pieces of the ecosystem functioning, we really will be able to make a mark and really Canada can punch above its weight in this medical isotope space. The key partners that we're working with at Triumph are the Center for Drug Development and Commercialization, Bruce Power, Canadian Nuclear Labs in Chalk River, McMaster University, Canada's Nuclear University, BWXT Medical, and of course Triumph Innovation. So we hope to make some significant progress on this funding initiative, and we hope that it's really just the start. Part of what we're asking to build is funding for networking and collaboration building. So how do we get more of our biological target validation specialists to interact with more of our radiochemists to sort of develop this next generation of drugs? How do we work together to increase the supply of medical isotopes? All of those pieces are things that we really have an opportunity here to lead in that leverages billions of dollars of infrastructure investment that's been made to date in Canada. And I think with that, I will stop and see if there are any questions.
Thank you so much for that, Catherine. If there are any questions, please let us know in the Q&A. We encourage you to ask questions to our speakers. Do any of the other panelists have questions for Catherine?
I have a question. I was just wondering for the treatment for the prostate cancer, how many labs in the world are manufacturing, or I'm not sure if manufacturing is the right word, but producing those isotopes? Is Canada a leader there, or are there others?
Canada is definitely a leader, and I'm a Canadian, and so I of course we all want to think Canada is a leader, but truly medical isotopes is one of the few sectors where we can legitimately say in the world Canada is a global leader in this space, and I think it has to do with the investments that Canada has made over the decades in reactor technologies and cyclotron technologies. So literally people from all over the world contact us at Triumph and ask us if we are able to supply them with these rare isotopes. And so it's an opportunity that I think we can capitalize on, but the world is moving quickly. When Novartis is spending, I think they've spent something like $8 billion in this space, other people are going to move in. So I think we do have to work hard and work together to maintain that leadership role.
Excellent, thank you.
We have one question from the chat. So this is a great initiative. Could this initiative proceed without the nuclear power generators? People don't know or understand the connection between medical and power generation.
It's quite new. And Bruce Power and Ontario Power Generation are kind of pioneered work in this space. So there are certain isotopes that can be made using certain methods. So some isotopes can really only be made using reactors. Other isotopes can really only be made using cyclotrons. So lutetium-177, which is some of the data that you see there, that's very exciting. It's a reactor-produced isotope. And so you do need a reactor. Does it have to be a power reactor? No, but I think that one of the exciting things is that, we can produce the power that we need and also be producing using the same reactor that's already producing the power, leveraging that leftover reactor capability to produce these medical isotopes.
Thank you so much. In relation to cyclotrons, there's another question. How many cyclotrons does Canada have?
Oh, that's a good question. So at Triumph, we have 6 on our site. There are many very small cyclotrons in really bench tops in hospitals. So I think there are dozens across Canada, ranging from size to, as I said, something that is the size of like a photocopier to ones that are the size. So the one at Triumph is 18.3 meters in diameter. So they fall somewhere along that range. A lot of the medical cyclotrons are kind of the size of like a minivan sort of thing. Our TR-24, which is a 24 million electron volt cyclotron, sort of fits in the size of like a dining room set. You know, it's sizable, but a lot of the size of the facilities relate to the shielding that you have to have. So you have to have a lot of concrete around it, and for it to be able to operate safely. So there are dozens. Not all of them can be used to produce medical isotopes. Some of them have to be a certain power. Some of them have to be a certain size. So there's all these different variables to what can actually be produced on any specific cyclotron.
Awesome. Thank you so much. Thank you so much for your talk and answering all the questions. Catherine, we will be moving on to the next talk, which will be presented by Dr. Claire Brown from the Canadian Network of Scientific Platforms.
Excellent. Thank you for the introduction. Just share my slides here. And I'll just double check. Are you seeing the correct screen?
We are.
Yes, we can see the correct.
Thank you. So I'm happy to be here. I'm the co-founder and president of the Canadian Network of Scientific Platforms. And today I'd just like to tell you a little bit about our network and what we do. So I wanted to start with a definition. When we started the organization, we really thought carefully about how to call the network. And so I wanted to tell you a little bit about what scientific platforms are. So they're centralized shared laboratories that often can leverage the economy of scale by putting specialized instruments and or services into a centralized location. And the most important thing about them is that they have dedicated experts or platform scientists who can support researchers and trainees in training them in advanced technologies and applications. And these platform scientists are often multidisciplinary in that they know a lot about the technologies, but they also know a lot about the model systems people may bring and the acquisition and data analysis techniques that they would need. It's usually an open center that's open to the community within the institution, and often they're open to external researchers as well. And they typically occupy discrete units or dedicated space. So it's not just an instrument in a single research lab, but it's in a centralized space where it's open for the community to use. So the Canadian Network of Scientific Platforms was formed in 2016, and we really wanted to come together as a community and discuss similar challenges that we have across Canada and share ideas and brainstorm solutions to these challenges. We wanted to build up our community so we could share resources and provide professional programs for our membership. One example was near the beginning of the COVID pandemic. We got together through virtual meetings and talked about how to safely reopen our labs. And so these centers were naturally used by many, many researchers. So we had a lot of careful considerations to be made to safely open. So we got together, had conversations, and developed shared operating procedures for the whole community. So we're able to do that really quickly as a group. We've also connected with similar networks across Canada and internationally, so we can learn from them and bring the best practices to Canada quickly. And I'll tell you a bit more about, we've tried to have a uniform voice to engage stakeholders. Communities of these platforms are tremendous, but there's not a lot of awareness of what they are and how they aid the scientific mission of Canadian researchers. And we're a nonprofit entity, so we're able to apply for funding for the network and for our membership base. So the network currently is made up of 194 platforms across Canada, and we represent about $1 billion of research infrastructure spending. Most of this is through the Canada Foundation for Innovation, with matching funds from the provinces and corporate partners. You can see from the list here, this is not a complete list, but just to give you an idea of the type of facilities that are part of the network, they range all the way from engineering to health sciences, including things like nanofabrication, light microscopy, and animal cores. You'll see we also have a bit of a concentration in Quebec with 81 platforms, and that's because our group did emerge out of Montreal. So we have 31 member institutions, and these are institutions who signed a letter of commitment to join the network. And we also have more institutions in terms of membership through the different platforms that we represent. And you can see from the number of institutions here that we represent universities, hospital research institutes, and government labs. So we have 4 pillars that we focus on to bring excellence to science. And the first one is advocacy, where we really are trying to raise awareness about what these scientific platforms are and really advocate for the people working in the platforms. These people often fall through the cracks in that they're not trainees, they're not graduate students and postdocs, but they're also not research faculty. And so often they kind of get forgotten in terms of professional development opportunities and travel and fellowship opportunities, and even writing grants and so on is not possible. So we've really been trying to just create awareness that these are real expert scientists who are a key part of the whole research ecosystem in Canada. And along that line, they have a huge role in education. So I run the advanced bioimaging facility at McGill. And for instance, last year we ran 220 one-on-one training sessions with graduate students and postdocs, where one of my staff will sit with the trainee for 2 or 3 hours and really show them how to use an advanced light microscope for their specific application. So this is really valuable for training the next generation of scientists. We also focus on professional development because, as I mentioned, the members, the platform scientists often don't have access to that kind of training. So we try to provide the training as well as financial support to travel or register for training. And then we are really trying to build our network by reaching out to other communities around the globe and making sure that we are working with the best practices of community building and delivery of research infrastructure and expertise to the scientific community. So these platforms are really a hub of activity. We interact with academic researchers. And as I mentioned, we train the next generation of trainees as far as graduate students and postdocs. We maintain and quality control the infrastructure. And we also interact a lot with the companies. So we interact with the instrument manufacturers in that they're providing the technologies in our facilities. And we try to provide them with input of where these technologies could go in the future. And also we have corporate partners who are small biotechs or industry groups that need the technology and the expertise that we have. And so they're actually customers or users of our platforms. So I just wanted to bring up some of the challenges that we're facing and some of the solutions we propose. And I think probably the main challenge we have is that the platform scientists are typically paid out of soft money. And so they don't have a lot of job security and they don't have clear career paths. So we've been working with global organizations in order to develop clear career paths for platform scientists and make international recommendations that institutions can draw from in order to improve this. And we've been trying to really advocate and show the value of these platforms for institutions to see that these platform scientists are really a key part of the system that need to be funded and have stable positions so that we can keep the best people involved. We also want to build a national database of research infrastructure and expertise so that we can spread the word and make sure people can be connected to the instruments and the expertise that they need for their research. We also, I think number 3 is kind of similar to the first one I mentioned, that we really need dedicated scientists. A lot of these instruments are around $1 million, and we need people to really be with the researchers and become world experts on that technology so that they can ensure rigorous reproducible science is done. And then we'd really like to have more support for the network itself, because we'd like to be working with different stakeholders in order to come up with strategic plans to make sure the equipment is available and accessible to everyone. So I know that I'm out of time, so I won't read my statement here, but this is a picture from our first platform scientists meeting in 2017 in Montreal. And I'm happy to take any questions you might have.
Thank you so much, Claire. Are there any questions for Dr. Brown? Okay. You might have stated this already, but how many platform scientists are currently supporting platforms within your network?
Well, that's a good question. I could do a little bit of math. I don't think I would have the exact number, but it's a bit surprising, but a lot of the platforms have only one person. And this is one of the challenges we're trying to bring to people's attention. And we're actually running a workshop in May about that topic to see if there's ways we can help those people, because if they're on vacation or they're not there, then the instruments are not supported. So I would say many of the platforms, I would say probably at least half are run by a single person. And then others really vary anywhere from 2 to 10 staff. So I would say we're probably representing 500 or 600 platform scientists.
Thank you. Are there any other questions for Dr. Brown? Would any of the other speakers like to ask any questions?
I have a question. So Triumph is also a platform in many respects, and we are wrestling with the question of, we want great researchers, but a lot of it is like, we also want a good user experience for people that come. And so how do you balance that, where, you know, we have researchers that want to do their own research, they're interested in doing research collaborations, but they're less interested in helping, you know, all the users that come. So how do you incent the right outcomes and keep that platform widely accessible?
I think that's where it's really important to have dedicated platform scientists, that it is their job to help the other users. And I know for myself, in hiring people over the years, there are a lot of really talented researchers who don't want to start their own lab. And they love the diversity, working on many different projects and interacting with scientists. Like in our facility, we have people looking at material science and cancer and neuroscience, and they really enjoy that. So if you have somebody who's kind of doing their own research project, and then you say, can you also help all these other people on the instrument because you're an expert, it's kind of taking away from their passion and kind of why they're using the technology. So I think you really need those dedicated staff who that is very clearly what their job is. And they're creating more and more career paths for that as well. There's some programs in Europe and the US to actually train as a master's level of how to be an infrastructure platform scientist and to learn about the management and training and all those aspects as well. So.
Thanks, Claire. I might follow up with you on that. That might be a good
we can meet up in Ottawa.
Thank you so much. Thank you for all your questions, and thank you so much, Dr. Brown, for your presentation. We will be moving on to the next presentation, which will be presented by Dr. Jiwani Fusina and April Tunya-Wongs from Defense Research and Development Canada and the U.S. Department of Homeland Security.
Okay, hello. Good afternoon, everyone. I'm April Tunya-Wong. I manage the Americas portfolio for the U.S. Department of Homeland Security, Science and Technology Directorate, International Cooperative Programs Office. And I'm pleased to present this short talk on international STEM internships, science diplomacy, and global safety and security, along with my Defense Research and Development Canada colleague. DRDC's Center for Security Science coordinates investments to deliver science and technology solutions that advance Canada's capabilities to prepare for, prevent, respond to, and recover from high consequence public safety and security events. And in this capacity also serves as a science advisor to Public Safety Canada. The Department of Homeland Security Science and Technology Directorate engages in research, development, testing, evaluation, and demonstration of Homeland Security technologies to advance the department's mission of protecting the homeland. Science and Technology Directorate thus acts as the scientific advisor to the Secretary of the Department of Homeland Security. The Department of Homeland Security, S&T, and DRDC piloted an international internship program in 2022. The program offered internships to students majoring in sciences, technology, engineering, and mathematics disciplines, with direct safety and security mission application. For summer 2022, 2 students were selected as the first international interns and conducted research in public safety and security areas of mutual US-Canada interest in Ottawa, Canada. The goal of the internship was to promote a diverse, educated, and skilled pool of STEM professionals and a workforce experienced and passionate for international cooperation in public safety and security. Our objective today is to provide an overview of the intern program, the DRDC DHS S&T partnership, the students' research, and key takeaways to improve the next iteration. Next slide, please. So the iSTEM program leveraged the DHS Homeland Security professional opportunities for student workforce to experience research, or the HS-Power program. It's administered by the Department of Homeland Security S&T Office of University Programs, and it provides an internship opportunity for U.S. STEM students to work with safety and security personnel on international engagements in country. The HS Power program is managed by the Oak Ridge Institute for Science and Education, or ORISE. They offer competitive internships and fellowship programs on behalf of the U.S. Department of Energy and 15 other federal agencies. It's the only Department of Energy asset whose core mission is preparing the future federal STEM workforce through workforce development programs. So there was a strong history of STEM internships within the U.S. government, and even specifically within the Department of Homeland Security, but none with this international component. This was the first time that we implemented this program, and we quickly mobilized to determine if our DRDC colleagues were interested and able to support the in-country research projects, and we developed our objectives and then interviewed and selected the applicants, all within a matter of about 4 months time period. Our goal was to highlight for the interns the importance of international collaboration in science and technology as we confront our common public safety and security challenges. So why did we choose DRDC to jointly conduct this program and more broadly to do so in Ottawa, Canada? We've been working with our partners at DRDC since signing our 2004 treaty between the US and Canada governments, cooperation in science and technology for critical infrastructure protection and border security to support.
Next slide.
Oh, I'm sorry, next slide, sorry. To support our safety and security missions. DRDC and DHS S&T jointly administer this treaty. For some context around this partnership, the US and Canada enjoy the largest bilateral trade and investment relationship in the world. At 5,525 miles, or 8,891 kilometers, the US-Canada border is the longest shared land border in the world. The two countries are connected by more than 120 ports of entry, 200,000 annual US-bound flights, and the numerous commercial and recreational vessels that cross the maritime border. Every day, approximately 400,000 people and $1.6 billion in trade cross the US-Canada border. They also share common infrastructure and intertwined supply chains with a single good often crossing the border multiple times during production. Canada is America's largest foreign energy source, including the top oil and natural gas supplier. As such, we face many common threats and challenges in the public safety and security realm, including the effects of climate change, increased accessibility of the Arctic, and protecting our shared critical infrastructure and supply chains. Next slide. So the primary purpose of the international internship was an opportunity for short-term research projects focused on topics of mutual interest to the U.S. and our allies. It was to tap the next generation of STEM professionals to consider international science, technology, and innovation, and government service in particular, as there's strong competition for STEM professionals and STEM talent in the economy. The picture that you see there shows the three main institutions or three main offices that work together to create the iSTEM program, two of which are within the Department of Homeland Security Science and Technology Office, plus our colleagues at Defense Research and Development Canada. The Office of University Programs manages a complex and broad portfolio of scientific investments focused on the investigation, experimentation, and evaluation of emerging science and technology in response to DHS component needs. Next slide, please. So this slide is just one example of the presentations that one of the students completed at the end of this project, showing, highlighting the international and cultural aspects of their experience in Ottawa, along with their short research project that they completed during the time. With that, I will turn over to my colleague from DRDC, Dr. Giovanni Fusina, to talk a little bit more about the actual research projects.
Thank you. I'm Giovanni Fusina. I'm at DRDC Center for Security Science. I'm the Natural Hazards Portfolio Manager there. And my task was with the students, was to kind of mentor them in their short research project. And this kind of is sort of a humorous slide about their experience. But if you go to the next slide, please. So just to highlight some of the findings and the future research areas they covered. I mean, they had a tall task. In a few weeks, they were supposed to look at areas of cross-border relations between the US and Canada in the events of natural disasters and identify possible gaps and future research areas. One of the students was more of a technical background in engineering, and she focused on communications and during natural disasters between Canada and the US, and found that even though, well, first of all, found that there is some lack of coordination and communication between the different local, federal, provincial jurisdictions involved. However, on the technical end, as she researched these cause experiments, the Canada-US enhanced resiliency experiments, as these experiments showed, the problem is not so much in the technical aspect of coordinating, but more in the jurisdictional aspect. So that's one of the future research areas she highlighted going forward. Another area, there is no seamless flood risk map between US and Canada, for example, and that would be something that would be beneficial. If you go to the next slide, please. The other students was more in the social sciences, and sciences, and her research focused more on the inclusion of Indigenous knowledge in the natural hazards domain. Some of her findings was that a middle organization between provincial jurisdiction and First Nation jurisdiction would be beneficial in the inclusivity of these Indigenous communities. For example, the First Nations Emergency Services in BC. If you go to the next slide, please. We are working on a report that will be published through the DRDC publication process for their work. And the overall experience with them was that students give fresh new perspectives on issues that we are aware of, but may not think about what their point of view is. They helped us expand our research networks, which was good. A way to team build between the US, DHS, and Canada, DRDC. The one thing that could be improved is the length of the internship, which was way too short to have perhaps a more detailed research report published. And if you go to the next slide, this is just the list of all the different agencies, that these students had meetings arranged with and contacted and got feedback from in developing their research project. I'm sorry we went a little bit over time, but I rushed through the last slides, but that concludes our presentation. Thank you very much for your attention.
Thank you so much for the presentation. Do we have any questions? If you have any questions, please put them in the Q&A chat. In the meantime, do any of the other speakers have any questions? We have one question in the Q&A. What's retention like for the scientists who are in the program?
I'll take that one. I honestly can't answer that because this is our first interaction with the program in the international capacity. So I'm not sure how many that they have come on board with the government following these science internships in the other departments.
Thank you so much. Are there any other questions? Okay, thank you so much for the presentation. We'll move on to our next short talk, which will be presented by Tony Bassett from...
Oh, hi there. Thank you very much. I'm going to load up my screen here, presentation. There we go. Can everybody see that fine? Okay.
Yes,
first of all, I'd like to welcome everybody to the presentation. I'd like to thank the CSPC for inviting me. It's a privilege and an honor to be here talking with you today. This presentation is about the agents of disinformation and how external forces have adversely affected the narrative around science and created doubt about the merits of science and the effect it has had on science policy. So a little bit about myself. I work at Genome Prairie here in Saskatchewan, Saskatchewan. I have a master's degree in political science from the University of Saskatchewan. My thesis examined how disinformation has affected science policy using neocolonial, Marxisian, and path dependency theories. And this presentation is going to be a very concentrated distillation of my research, very concentrated distillation. So here's the question. Why is there so much public distrust in science? Well, the reasons are complex, but this has been going on. This distrust in science has been going on for nearly 100 years. Let's go and take a look at the early example of this. And this is an ad from the 1940s. And here we have a doctor relaxing and having a cigarette and talking about how wonderful cigarettes are and how healthy cigarettes are. And this was a common advertisement that we saw about 80 years ago. Why should we care about an old tobacco ad? Well, because that kind of advertisement had a profound effect on how other people or other organizations advertise. This is an ad from 30 years ago from the lobbying group Informed Citizens for the Environment, talking about how climate change and global warming was chicken little. It was completely overstated. It was nonsense. This is from 20 years ago. These are ads from the New York Times, Wall Street Journal, from the Exxon Mobil oil company, talking about how the science of climate change is completely unsettled, and there was great divisions of opinions among scientists. Of course, that was totally false. The campaign for science has been going on for nearly a century, and that sort of led us where we are today about doubting the merits of knowledge of science. And my research has focused on three main influencing areas, or three main factors of why there is so much doubt. One is the influence of external groups. We saw a little bit about it before there in that advertisement. Two, the influence of deregulation. This has been going on for about 40 years. And three, motivation to use this information as a means of making money. So let's start with the first main influencing factor. The one is the influence of external groups. And I'm going to talk about a couple of them. One is the U.S. Tobacco Institute, and the other is the American Petroleum Institute. They are two classic examples of influence. The U.S. Tobacco Institute was formulated by tobacco companies who knew a long time ago that their product was killing people. And so the Tobacco Institute put together a strategy to counteract that information that was being found out by scientists and medical officials, is saying, hey, this stuff is killing people, by putting together campaigns, much like the advertisement we saw before, where we had doctors, fake doctors, posing that the cigarette smoking was healthy. They knew full well that this information coming out from science was a threat to their industry, and they were counteracting that by questioning the merits of science and research. Well, that worked very, very well and held off a lot of legislation against tobacco for 40 years. And the oil industry saw that and said, that's a perfect model for us to use, because we're having all of this science and research coming forward about climate change and global warming. And so what they would do is they would hire people, for example, like academics. Robert Bawley Jr. is a notorious example. He worked at Arizona State University. He would put forward articles that would contain quotes like this, saying, hey, climate change is good for the environment. Driving your car around is great for the environment. You should do it more often. The second factor is deregulation. This is something that's been going on for at least 40 years. And it was very, very big in the 1990s. And here is a 1996 photo of an act being signed by President Clinton and Al Gore, who became famous for the documentary An Inconvenient Truth. And they were signing the Telecommunications Act of 1996. Now, why is that important? Well, it was a deregulation act that allowed for media conglomeration. What did that lead to? Well, it led to the development of very, very large media networks like Fox News. And Fox News was driven by its bottom line, driven by motivating to make profit. So we saw other examples of media conglomeration on the radio airways. Rush Limbaugh became a very prominent voice, a very good speaker. He was an outstanding speaker on the radio. And he was a main figure person for questioning the merits of science. And he often attacked government, academia, and science as a source of evil, essentially. And his campaign went on for quite a few years, and he had a very loyal and large following. But that narrative and that kind of messaging had a cumulative effect. So if you sort of were a consumer of this kind of for-profit media, your opinions about things like climate change were going to be very skewed. So if you're a consumer of, say, for example, Fox News, you are under the opinion that, hey, there's division among scientists about whether climate change is real or not. But if you weren't a consumer, that opinion was drastically different. And you could see the effect on the public about science. So the third influencing factor is, hey, disinformation can be very lucrative and very profitable. John Donovan from Baltimore University wrote extensively about this, and she has some fascinating work. Here's a pyramid chart that went very, very viral, just to sort of back that up, by Abby Richards a few years ago. It's an inverse pyramid chart talking about conspiracy theories. And if you look at the bottom of the chart, we can see things that are sort of considered conspiracy theories, but they're actually the truth. And this chart mentions things like Watergate and big tobacco lying about cancer. But if you move further up the chart, you can see things get a little wilder, and they're totally disconnected from reality. And the very top or bottom of the pyramid chart talks about things like QAnon, the Flat Earth Society, George Soros. There's a lot of wild stuff. There's some xenophobia, there's some racism mixed in there. But these things you see at the top are very current. because they're very focused on disinformation. And this is a very current thing that's happening right now. How lucrative is it? It's extremely lucrative. This is a man, Alex Jones, who has made many, many millions of dollars indulging in conspiracy theories, and he's attracted an extremely large following, and he's made a lot of money from it. So how can we overcome this disinformation in the questioning of science? I have two proposals for how we overcome this. One, I think it's extremely important that we fund avenues of public broadcasting to move away from profit-driven information gathering sources to information gathering sources that are in the public interest. I'll give you an example of that. Here's a survey that was done a few years ago, and it examined countries that had a lower opinion of scientists, and we find that the countries that had sort of a lower opinion of scientists included India, the United States, and Canada. And those countries had a much higher opinion about scientists, and they were included the Netherlands, Spain, and Germany. If you look at public funding for public broadcasting, we find that the countries with higher funding for public broadcasting had a higher opinion of science and scientists, and those with lower support of public broadcasting had much lower opinions of science and scientists. The second is connecting with people. This is the groundwork stuff that science and scientists have to do in order to reverse this trend of questioning the merits of science. I'm going to use a case example from the Arkansas game and fish experiment. This happened a few years ago, and Austin Booth, who is the director of the Arkansas Game and Fish Commission, put forward this the system in place, strategy in place to help put forward a very controversial decision. What was happening in Arkansas is every fall they had levees. They would open up the levees and it would create a floodplain. And this floodplain would be artificial, but it would attract a lot of ducks who love, migrating ducks who love water sources, and they would float around, and duck hunters would go there and they would shoot a lot of ducks, and it was a great place to do duck hunting. But they found that in opening these floodplains and opening these levees, it was killing a lot of the forests in southwestern Arkansas. And so the decision was made to not open up these levees, which didn't create these artificial floodplains, which didn't attract the ducks. So the duck hunters were not going to be very happy about it. So what was the solution? Well, what Austin did is he said, well, let's take a very grounded approach. Instead of just doing it and saying, well, that's how we're going to put forward this policy, let's make a greater connection to those who are affected by it. Let's communicate them on the ground. So he put together a series of community meetings where he would talk to people, make face-to-face contacts and communications. He would sit down for dinners with people in large town halls and community centers and explain the problem and make that human connection and getting out and talking to people. And that had a very beneficial effect. It created buy-in, it created understanding among those who were affected by this policy. And creating that understanding, it also created a change in opinion about the work that Austin was doing and the commission was doing in identifying the problem and determining the solution. Final words. You know what? We've got a large problem about questioning the merits of science. So we can't do it from behind our desks. We have to get out and we have to talk to people. We can't talk from above. We can't talk from a pedestal. We have to make that human connection. We have to make that on-the-ground connection and talk to people and communicate with them and change hearts and minds. It's tough, grinding work, but that's what's going to be necessary in changing the narrative and changing the perceptions about the merits of science. That's my presentation. I'm welcoming questions. If anybody would like to inquire about some of the research work I've done, that's my email contact down there. You can contact me at any time. Thank you all for this time to present.
Thank you so much, Tony. We do have questions in the chat. We have a question about the 1987 repeal of U.S. Fairness Doctrine by Ronald Reagan, and whether you think this could be a second influencing factor.
100%. And that's actually part of the research work that I did. And I just didn't include it because I didn't have the time. But that was the first primary act of deregulation, was the revoking the fairness doctrine, which essentially, because we had the media become more profit driven, the bottom line, so it was very corporate. The corporate fund, it received a lot of corporate funding. There was only been one-sided conversations that have been going on the airways, and that's usually in the interests of say corporations, and putting that message out. And the corporations are like the oil industry, the tobacco industry formerly, were very motivated to question the merits of science and research, and undercutting that. And so and then the repeal of that fairness doctrine, I think, with also the Telecommunications Act, had a very profound effect. And I just want to have the opportunity to say one thing. If you watch this presentation, you say, well, this is all American stuff, because, but I think it's very important, because what happens in America, especially when it comes to information, and the dominance of the American culture, especially in the Western Hemisphere, has a profound effect throughout the world, and including Canada. So what's happening and what has been happening in the States, you can find it here in Canada as well. There's still also significant questioning of the merits of science that we see in this country, as we also see in the United States.
Thank you so much for that answer. We have another question. With respect to reducing disinformation online specifically, in your opinion and from a policy perspective, to what extent are governments responsible, and to what extent are large tech companies responsible?
Extremely responsible. Governments have the ability, if they so desire, to put forward measures to regulate some of the conversations or the disinformation, especially we see in social media. And you see within Europe, some countries in Europe and the European Union have put in regulations that affect social media, which I think has been a very large impact in creating this disinformation or questioning the merits of science. And the tech companies, again, they have a moral obligation, but they also, in their minds, have an obligation to their shareholders. And so Facebook and Twitter, they look at that and they go, well, you know what? It's creating an audience for us, and it's helping our bottom line. So they're not particularly motivated to enforce any changes. And so because of that, I really do strongly feel that there's a role for governments to play, to sort of say, hey, we've got to bring some sort of measures into place to ensure that the general public are well informed about things that are factual.
Thank you so much. We do have another question, actually circling back to talking about the US. How is Canada doing compared to the US?
Not well. Canada, it's sort of like Pierre Trudeau said, that we're a mouse sharing a bed with an elephant. And so when the elephant twitches, you feel it. And so the American influence is very prominent in this country, and it's growing much more so culturally, and as far as information is concerned. And so Canada, much like the United States, has taken a very deregulatory approach to the disinformation that we see, especially in social networks. And Canada, we do have a public broadcaster, but to be quite frank, we do a very lousy job in supporting of public broadcasting here. It's been a target by governments for the past 30 years of cutting budgets to there. So our support for public broadcasting in this country is not much better than the United States, which in the United States it's basically non-existent. And I believe that that has had a significant effect upon the public's understanding about the merits of science. And we see that in Canada, with the vaccine debate, so-called debate. It's just been as significant here as it has been in the United States. And I'm not particularly surprised by that. It's unfortunate.
Thank you so much for your answers, and thank you so much for your presentation.
Thank you.
We will now have our final short talk presented by Andrew Atkinson from Health Canada.
And thank you so much. So my aim here today is to introduce a set of principles for responsible innovation in neurotechnology, which were developed by the Organization for Economic Cooperation and Development, known as OECD. Another acronym you'll be hearing today is BNCT, which refers to the OECD Working Party on Biotechnology, Nanotechnology, and Converging Technologies. So that's quite a mouthful. In terms of my role, although I'm with Health Canada, I'm part of a broader Government of Canada delegation who are members of this BNCT. BNCT members represent Government of Canada as a whole, as well as broadly representing Canada's interests. Okay, next slide. So what is neurotechnology? Simply speaking, neurotechnologies are devices or methods used to interact with, analyze, or better understand the brain. These include hardware connected invasively or non-invasively to the brain. This integrates software and applications, artificial intelligence, etc., to process and analyze the various forms of data collected. Examples of neurotechnology you might be familiar with are brain-computer interfaces and deep brain stimulation. And next slide. So why OECD? So big picture, OECD convenes member states on a multitude of issues towards the development of consensus policies and guidelines, basically for the good of society. In the context of emerging technologies like gene editing and synthetic biology, they can offer societal benefits like economic growth and well-being, but they may also bear negative consequences. So OECD aims to develop policies supporting the safe and inclusive integration of emerging technologies into society. Also of great value, OECD is able to examine a full spectrum of issues that may or may not fall under the federal jurisdiction of member states. So it's really an ideal forum for broader conversations. And next slide. So turning to the OECD recommendation itself, OECD recognizes that neurotechnologies play an important role in the diagnosis and treatment of mental and neurological disorders. In fact, 1 in 3 Canadians will be affected by brain or nervous system illness in their lifetime, and the current cost to the Canadian economy is estimated to be $61 billion per year. So, while approaches to brain health are urgently needed, neural technologies, they raise a range of unique ethical, legal, and societal questions, issues surrounding brain data privacy, manipulation of personal autonomy, and dual use. So this recommendation takes into account that the governance of nanotechnologies affects the entire innovation pipeline, from fundamental brain research to commercialization and marketing. This means all stakeholders have a role to play, and meaning governments, innovators, healthcare providers and advocates, industry, and the public. Also note, as Canada is a OECD signatory, these recommendations are not legally binding, but they do entail a moral and political commitment. OECD is now encouraging all member states, including Canada, to develop strategies to socialize and implement the recommendation. Next slide. So just a brief history. Over a period of 5 years, BNCT led extensive stakeholder and expert consultations, and OECD adopted the recommendation in December 2019. And I will say, like during the consultation process, Canadian opinion leaders were very well represented in the consultation exercise. The recommendation itself consists of 9 principles, which will provide guidance at each stage of the innovation pipeline. And I'm about to run through a very quick, simplified overview of the principles, but the full details are posted on the OECD website. Okay, next slide. So turning to the principles. Principle 1, promoting responsible innovation. This stands as an overarching principle. It speaks to broad issues such as the promotion of beneficial applications for health and where needs are greatest. It asks for the integration of ethical considerations in the development of neurotechnologies and regard for human rights and societal values. Next slide. Principle 2, prioritizing safety assessment. That, of course, is a principle close to Health Canada's mandate, and it encourages strong stakeholder engagement. And in addition to standard considerations of harm reduction, it also considers the concept of autonomy, which is the essence of someone's personality. Safety also includes issues related to cybersecurity, for example, ensuring devices cannot be hacked. Next slide. Principle 3, promoting inclusivity. This includes fostering a policy environment that advances the inclusion of underrepresented population in the continuum of the innovation process. And next slide. Principle 4 addresses fostering scientific collaboration across a range of stakeholders, but given the nature of neurotechnologies, we must engage many disciplines like computer scientists, cell biologists, clinician, and patient communities. It encourages the development of standards and best practices for the technical as well as ethical, legal, and social aspects, and fostering an international culture of open science. And next slide. And I should be on Principle 5. Yeah, Principle 5. Principle 5 calls for the societal deliberation as a critical component of the recommendation. This includes integrating a diversity of perspectives into decision-making processes, policy, and governance. Next slide. Should be Principle 6. Principle 6 addresses enabling capacity of oversight and advisory bodies to help guide the direction of technology and help address novel issues such as biases in artificial intelligence. Next slide. Principle 7 addresses safeguarding personal brain data and other information. And this includes ensuring that means of obtaining information and informed consent are adequate. And next slide, Principle 8, that promotes the cultures of stewardship and trust across the public and private sector. Examples would include considering the development of institutional and company level principles that promote accountability, integrity as part of the R&D process. And next slide, which is lastly Principle 9. This addresses anticipating and monitoring potential unintended use and or misuse of neurotechnologies. This promotes mechanisms to anticipate and prevent potentially harmful unintended uses before neurotechnologies are deployed. So next slide. So that was a lot of information on principles, but in terms of next steps, BNCT is currently developing a guidance document to support these principles, listing practical actions that various stakeholders can undertake. This guidance document will include a collection of best practices and case studies and is supported by a neuro advisory network. And again, I'll say this network is also well represented by Canadian opinion leaders. In addition, Health Canada will host a CSPC panel discussion on how the OECD recommendation will translate in Canada. And this is part of the CSPC virtual series on Tuesday, May 16, 2023. And a big thanks to CSPC for giving us an opportunity to put a spotlight on this initiative. Okay, thank you so much.
Thank you so much for the presentation, Andrew. We have one question in the chat. How do you see implementation in Canada and what are other countries doing?
Yeah, that's a very interesting question. OECD is kind of working hard to socialize this within member states, and they're having, they're struggling with uptake in some jurisdictions. Some jurisdictions are really running with this. France, for example, has put together a so-called charter, which is essentially a summary, which is, if I could say, more plain language written than OECD fare, that companies and institutions can sign on to. And, that gives them an opportunity to kind of showcase the fact that they recognize these principles and they commit to adhering to them. Switzerland is taking a kind of a lesser approach in terms of, just submitting a survey out to the, broad stakeholders, sectors, just to make sure they're aware of it. And here in Canada, it is a complex landscape. So our intent is to leverage CSPC in terms of standing up that panel, bringing together Canadian opinion leaders, and getting advice on what would best work for Canada.
Thank you so much. Are there any other questions? Please, if you have any other questions, please put them in the chat. We do have one. What kind of neurotechnologies are we seeing for the treatment of psychosis?
Good question. I will say I am not a kind of technical expert in the actual technologies themselves. But, indeed, the development of technologies is also varied. So, like, for example, like DBS is a potential technology that could assist. But, certainly we look at the range of potential neurological issues. Some may be addressed by kind of external medical devices, and some will require some sort of implant. So the implant technology is certainly still very much a work in progress.
Thank you so much. If there are any other questions, please put them in the chat. Do any of the other panelists have any questions for Andrew? Thank you so much, Andrew, for that presentation. And thank you so much to everyone who sent in questions. So that was our final presentation for this session. I would like to thank everyone who attended the session and sent in their questions. I would also like to thank all the speakers for their time and their presentations. We do encourage you to stay tuned for future pre-conference events and to check the CSPC website and social media for all the details. We will be launching a short poll for your feedback, so we request you to please fill that before exiting the session. Thank you so much, and have a good rest of your day.